Energy thickness. So here, as in the previous thickness, I think displacement thickness and also the momentum thickness, we have discussed about two cases. So one is with the plate and another one is without plate. So here you assume that there is no plate, here there will be a plate. So over the surface and over the plate we are going to pass the liquid, we are going to pass the fluid. So the velocity effect will be, in first case, will be like this, right? So velocity will be constant, there is no change in velocity. So we are representing this as capital U, right? But in second case, your velocity will be changing like this from 0 to, when the fluid strikes on the plate, velocity getting 0 and gradually it is increasing, and at some height it will reaches the free stream velocity. The whatever the velocity before strikes the plate, the same velocity will reach at some height, right? So that height will be, we are saying when you mark this height, so this height is changing from the leading edge of the plate to everywhere along the plate, right? So this is your boundary layer. This height is boundary layer thickness, right? So this boundary layer is formed only by placing the plate only. So this cannot be formed without any plate, right? So this is very, very important, right? So from the boundary layer only these thicknesses are arising. So very first thickness is boundary layer thickness. This boundary layer thickness is changing from place to place along the plate, right? Here if you look at the boundary layer, here at this position is very small, and here it is increasing, right? So slowly it is increasing, right? So the boundary layer thickness is changing from place to place, right? So let us come to energy thickness. Here the velocity is capital U, I told, and here the velocity will be small u, because why we are keeping small letter? So here the velocity is changing with respect to height, y, right? With respect to vertical distance, velocity is changing, right? So now let us take a small strip here, and in second case also small strip or small fluid element, right? For the small fluid element we can give height is dy, and here also you just give a height is dy. Why we are taking height is because based on the height only velocity is changing here, but here it is constant in first case. And if you take a horizontal dimension is breadth b, because whenever the fluid is flowing along the surface it will be facing only the breadth surface and also vertical surface dy, right? So that means when the fluid is flowing along the surface or plate, it will be facing only these two dimensions, b and dy, right? So now what is energy? What kind of energy we are going to look at here, right? So that is nothing but kinetic energy. Kinetic energy general formula is half mv square, right? Of mv square. We already have seen, we already have abbreviated the mass formula like this, half into rho a into v square. So this is your mass, right? For first case your kinetic energy will be, for first case without plate, that is along the surface, so half into density, your area will be as in previous thickness, b into dy area, into velocity small u only, right? And u square will be capital U, because here the velocity is constant. So this is for first case. And for second case your kinetic energy, this is for first case without plate, and for second case your kinetic energy half into rho same area b into dy into your velocity small u only, and u square also will be small, because here the velocity is changing with respect to height, I told you, right? So the here u square only, also small u square, right? So now as like as our previous thicknesses, we are going to decrease in energy. So how much energy is decreasing from first case to second case, right? Kinetic energy loss per second, right? So you have to subtract these two things. So here first one and second one, 1 minus 2, right? So 1 minus 2 is how the common term you can take it out. So half is a common term, and rho b dy, right? Rho b dy into u, these are all the common term, right? And this capital U square minus small u square, right? So, and then the total, if you want to calculate the total kinetic energy loss per second, right? So we are going to introduce a integral symbol, 0 to del, right? So total means, so now we have calculated the energy decrease for the small section of fluid in two cases, right? For whole height, if you want to calculate the loss for the whole height, right, from place of the surface of the plate to boundary layer, so you have to use the integral symbol, integration, right? And the limit will be 0 to del. So you can write like this, half b dy rho, also rho b dy into u square minus small u square. You can bring this dy at last, right? Your dy can be at last, right? So finally, here also we are going to do the same thing. Here also we are going to introduce a small thickness, that is energy thickness. So by introducing that thickness, right, either you can raise the thickness of the plate or raise the surface, right? So by doing like that, you can avoid your energy losses, kinetic energy losses. So when you introduce a thickness, small thickness up to this, if you introduce a small thickness and give a name like this del double star, right, your kinetic energy will become like this, right? Your kinetic energy will become like this, half into rho into breadth is same, height will be, instead of dy you can use del double star, right? And capital U cube, right? Because here the velocity is u only, right? So the total, here we are going to introduce the thickness without surface in this first case, right? So now you just write the whatever the decrease in energy, that is total kinetic energy loss, integration of 0 to del, half into rho b u into capital U square minus small u square into dy. In this case you can remove the common terms, half rho b, right? Yes, that's all. So finally your del double star is equal to 0 to del u by u cube into u square minus small u square into dy, right? So it will become yes, if you take the commonly u square out, it will be like this, u by u into 1 minus small u by capital U into dy. So this is your final expression of energy thickness, right? Thank you.